Imagine you're sitting at your computer and type google.com. You press enter. And within a second, Google's homepage appears. But here's something most people never think about. How did your computer know where Google is? After all, computers don't actually understand names like google.com. They communicate using IP addresses, like this one. So who translates a website's name into an IP address? The answer is DNS, or the domain name system, often called the Internet's phone book. But DNS is much more than just a phone book. In this video, we'll follow a DNS query from beginning to end and explain every major component along the way. DNS stands for Domain Name System. Its primary job is simple: convert human-friendly names, like how these sites transform into IP addresses that computers understand. Without DNS, every website you visit would require memorizing long strings of numbers. Instead, DNS performs that translation automatically, in milliseconds. Let's say your computer has never visited google.com before. The first thing it does is ask a recursive resolver. This resolver is usually provided by your internet service provider, Google DNS, Cloudflare DNS, Quad 9. Think of the recursive resolver as your personal researcher. Its job is, don't worry, I'll find the answer for you. If it already knows Google's IP address from a previous request, it immediately returns the answer. If not, the search begins. The resolver first contacts one of the root DNS servers. There are only 13 logical root server identities, operated by multiple organizations around the world using hundreds of Anycast server instances for resilience and performance. The root server doesn't know Google's IP address. Instead, it replies, I don't know where Google is, but I know who manages all .com domains. It then points the resolver toward the .com top-level domain servers. The resolver now asks a top-level domain, or TLD server. Since Google ends in .com, the resolver contacts the .com name servers. The TLD server still doesn't know Google's IP address. Instead, it replies, the authoritative server responsible for google.com is over there, and sends back its address. Finally, the resolver contacts Google's authoritative DNS server. This server is the source of truth. Unlike the previous servers, it actually stores Google's DNS records. It replies with something like, this site is equal to this IP address. The recursive resolver sends this answer back to your computer. Your browser now knows exactly where Google's web server is and can begin establishing a connection. Now imagine millions of people searching for Google every second. If every request had to travel through the entire DNS hierarchy, the internet would be incredibly slow. That's why DNS uses caching. After the resolver learns Google's IP address, it temporarily stores it. The next person requesting Google gets the answer immediately, without contacting the root, TTLL, or authoritative servers again. But how long should that information stay in cache? That's determined by the TTL, or time to live. TTL tells resolvers how long a DNS record can be cached before it must be refreshed. For example, a TTL of 300 seconds means the cached record is considered valid for 5 minutes. Once the TTL expires, the resolver performs another lookup to ensure it has the latest information. One problem with traditional DNS is that it was never designed with security in mind. Attackers can sometimes attempt DNS spoofing or cache poisoning, tricking users into visiting fake websites. That's where DNSSEC, or Domain Name System Security Extensions, comes in. DNSSEC adds digital signatures to DNS records. Instead of simply trusting an answer, resolvers can verify that the response actually came from the legitimate, authoritative server and wasn't modified along the way. It's important to note that DNSSEC doesn't encrypt DNS traffic. Its purpose is authentication and integrity, making sure the DNS response is genuine and hasn't been tampered with. So the next time you type a website into your browser, here's what really happens. Your computer asks a recursive resolver. The resolver contacts a root server. The root points to a top-level domain server. The TLD points to the authoritative DNS server. The authoritative server returns the IP address. The resolver caches the result according to the TTL. And finally, DNSSEC, when deployed, helps verify that the answer is authentic. All of this typically happens in just a few milliseconds. It's one of the fastest and most important systems powering the internet. Every website you visit starts with DNS. Without it, browsing the internet would be like trying to call someone without knowing their phone number. Now, here's a question for you. If DNS disappeared for just 1 hour, how much of the internet do you think would still work? Let me know your answer in the comments. And if this video helped you understand one of the internet's most important technologies, don't forget to like, subscribe, and share. Your support helps more students, aspiring network engineers, and cybersecurity professionals learn the technologies that keep our digital world connected.